Welcome to the course Methodology in Teaching Mathematics. This course allows you to learn about emphasis in teaching mathematics, Polyus problem-solving model, research-based teaching methods, and daily lesson plan. There are useful animations and interactive activities included in this presentation that can enhance your learning. You are able to participate while learning at the same time. Teachers of mathematics subjects usually do not often consider educational or pedagogical issues beyond a syllabus. It was assumed that teachers' responsibilities were only to present materials. Consequently, good students would pass and poor ones fail. Due to this problem, emphasis of teaching mathematics are developed with room for improvement. Teachers today are considered to have greater overall responsibilities of the teaching and learning, which take into account the role of instruction and the accountability of the teachers themselves. The teaching of mathematics in KBS-M is said to be more flexible for the teachers to implement an enjoyable, meaningful, useful, and challenging environment without sacrificing the students' progression in acquiring the mathematical concepts and skills. The main elements emphasized in the teaching of mathematics are problem solving in mathematics, communications in mathematics, reasoning in mathematics, mathematical connections, and application of technology. The main focus in the teaching of mathematics is problem solving. Problem solving skills are comprehensive and cover the curriculum in order to make sure that students are able to solve different kinds of problems. In solving problems, various strategies and steps are used. Among the problem solving strategies are to try a simple case, make trial and improvement, draw diagrams, identify patterns, make a table, chart, or systematic list, use simulation, use analogies, work backwards, use logical reasoning, and use algebra. In teaching mathematics, communication is significant as an essential means of sharing ideas and clarifying the understanding of mathematics. Only through effective communication, students will be able to solve problems, explain complex mathematical concepts, as well as share their skills to their peers and teachers. An effective communication environment can be created through the following methods. To identify pertinent contexts related with students' environment and everyday life experience, to identify students' interests, to identify suitable teaching materials, to ensure active learning, to stimulate meta-cognitive skills, to inspire positive attitudes, and to create conducive learning environment. Effective communication can be developed through two methods. They are oral communication and written communication. Click on each method to learn in details. Oral communication is a two-way interactive process which involves psychomotor activities such as listening, touching, observing, tasting, and smelling. It takes place between teacher and student, student and student, and student and object. Examples of oral communication activities include storytelling, asking and answering questions, conducting structured and unstructured interviews, having discussions during forums, seminars, debates, and brainstorming sessions, and making presentation of assignment findings. Written communication is a process where mathematical ideas and information are disseminated through writing. The written work is a result of discussion, people input, and brainstorming activities. Examples of written communication activities include doing exercises, keeping journals, keeping scrapbooks, keeping folios, keeping portfolios, undertaking projects, and doing written tests. The basis for understanding and solving mathematical problems is logical reasoning or thinking. Students are encouraged to estimate, predict, and make intelligence guesses in the process of finding solutions by using concrete material, calculators, computers, mathematical representation, and others. Logical reasoning is important because it helps students to recognize, construct, and evaluate predictions and mathematical arguments. Students can link conceptual to procedural knowledge and relate topics within mathematics in the existence of mathematical connections. By making connections of several areas such as arithmetic, geometry, algebra, measures, and problem solving, students can see mathematics as an integrated whole instead of a clutter of unconnected ideas. In addition, students will become more conscious of the significance of mathematics when mathematical ideas in a curriculum are connected to real life. In order to upgrade the pedagogical approach and to promote the understanding of mathematical concepts, the employment of latest technology can be taken into account. The use of calculators, computers, educational software, websites on the internet, and relevant learning packages help students in absorbing ideas, being creative, feeling confident, and being able to work independently or in groups. Besides, students also will be able to access knowledge or skills and information independently, according to their own pace, as these resources are designed for self-access learning. We have gone through in detail what are the main elements that need to be emphasized in the teaching of mathematics. To further enhance your understanding, let us look at these examples. Below are two different topics of Form 1 mathematics syllabus. Click on each topic to know its emphasis of teaching of mathematics. In the topic of number patterns and sequences, these are the emphasis. A. Encourage students to relate number sequence to patterns in daily life situations, such as odd numbers representing addresses of houses on one side of the road and even numbers representing the other. B. Use of calculators by students to skip count in order to generate number sequences, explore patterns of numbers, and solve problems. C. Encourage students to investigate and explore general statements about odd and even numbers. D. Use of calculators or computer programs by students to explore prime numbers. E. Encourage students to determine factors of whole numbers by exploring and investigating. F. Students explore and investigate to determine prime factors of whole numbers. G. Students conduct the divisibility test of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and their combinations. For example, 30 can be divided by 6. Hence, it can also be divided by 2 and 3, and vice versa. H. Plan games in order for students to find common multiples and lowest common multiple, LCM, through the methods of listing down the multiples of each given number, prime factorization, and algorithm. I. Plan games in order for students to find common factors and highest common factors, HCF, through the methods of listing down the multiples of each given number, prime factorization, and algorithm. In the topic of decimals, these are the emphases. A. Use concrete materials, drawings, calculators, and symbols to explain the relationship between decimals and fractions. B. Encourage students to compare and order decimals through the use of number lines. C. Use of calculators or computers by students to verify answers after solving problems which are related to everyday situations. D. Use of estimation strategies by students to determine whether the solution is reasonable. E. Plan games to motivate students to mentally multiply or divide decimals by 0.1 or 10. F. Encourage students to explore the application of concept by posing problems related to daily situations. In this topic, we have looked at the emphasis in teaching mathematics, which cover problem solving in mathematics, communications in mathematics, reasoning in mathematics, mathematical connections, and application of technology. The emphases are crucial as they provide guidelines for the teachers to implement an efficient way of teaching mathematics so as to enhance the understanding and develop skills of the students. In the previous topic, we have learnt about the emphasis of teaching mathematics. Now, we're going to learn in detail about problem solving using Polyus' problem-solving model. This model is developed by George Polya, a Hungarian who immigrated to the United States in 1940. His major contribution is in problem solving, as he later figured out that his interest was in mathematics rather than law, biology, Latin, or literature, the courses that he enrolled in. Polya had published a 2-volume set of texts known as Mathematics and Plausible Reasoning, 1954, and Mathematical Discovery, 1962. These texts form the basis for the current thinking in mathematics education. His contributions made him known as the father of problem solving. In Polyus' problem-solving model, there are 4 steps involved, namely, Step 1, understand the problem. Step 2, devise a plan. Step 3, carry out the plan. And Step 4, looking back. Step 1 emphasizes on how far students actually understand certain problem when they have to solve it. This is crucial because by understanding the problem, students will have some ideas about the problem and plan on how to solve it. Polya taught teachers to ask students questions to guide them to understand the problem better. Click on the button in order to view what type of guiding questions to be asked at this stage. These are the guiding questions to be asked. Do you understand all the words used in stating the problem? What are you asked to find or show? Can you restate the problem in your own words? Do you know what is given? Do you know what the goal is? Can you think of a picture or a diagram that might help you understand the problem? Is there enough information to enable you to find a solution? Is there extraneous information? Is this problem similar to another problem you have solved? In 1957, Polyus mentioned that there are many reasonable ways to solve problems. By solving many problems, the skill at choosing an appropriate strategy is best learned. As a result, students will find choosing a strategy increasingly easy. Click on the button below to view a partial list of strategies that can be implemented in solving the problem. These are the strategies that can be implemented in solving the problem. Guess, test, and revise. Eliminate possibilities. Consider special cases. Make an orderly list. Make a table or chart. Draw a picture. Look for a pattern. Look for a formula. Use a variable. Use symmetry. Use dimensional analysis. Use direct reasoning. Use indirect reasoning. Use properties of numbers. Use a model. Do a simulation. Solve an equation. Solve a simpler problem. Solve an equivalent problem. Work backward. And be ingenuous. This third step of carrying out the plan is usually easier than devising the plan. In general, all students need is care and patience, given that they have the necessary skills. Students need to be persistent with the plan which they have chosen. If the plan continues not to work, discard it and choose another. Do not be misled. This is how mathematics is usually done. Click on the button in order to view what type of guiding questions to be asked at this stage. These are the guiding questions to be asked. Can I follow through each step of the plan with the correct computation? Is each step correct? Can I prove each step is correct? Polyus mentioned that much can be gained by taking the time to reflect and look back at what students have done, what worked, and what did not. Teachers have to guide students in asking themselves questions once they have solved the problem, because by doing this, students are able to predict what strategy to use to solve future problems. Click on the button in order to view what type of guiding questions to be asked. Besides the guiding questions, teachers are advised to have a checklist for students to check the answer, whether it is correct or not for a given problem. Click on the button in order to view the checklist. These are the guiding questions to be asked. Can I derive the solution differently? Can I use the result or method for some other problems? Can I think of a simpler strategy? Can I think of a more effective strategy? Can I think of any alternative strategy? Can I extend my solution to a more general case? This is a checklist. Examine the obtained solution. Reread the question. Check whether you have answered the question. Check whether the answer is in the correct unit. Check whether the answer is reasonable. Check the result. And check the argument. In this topic, we have looked at Polyus' problem-solving model, which consists of 4 steps, namely, understanding the problem, devising a plan, carrying out the plan, and looking back. This model is important as it provides guidelines for the teachers to teach their students on how to solve a problem systematically and efficiently. What is the best way to convey concepts that are taught in mathematics courses so that all students can use and retain that information? How can the individual lessons be understood as interconnected pieces that build upon each other? How can a teacher communicate effectively with students who are unsure about the meaning of concepts they study? These are the questions that teachers need to answer in choosing the best method to teach. Therefore, in this topic, we are going to learn in detail about the 4 research-based teaching methods. There are 4 different types of research-based teaching methods that can be practiced in mathematics teaching, namely 1. Constructivism, 2. Contextual Learning, 3. Cooperative Learning, and 4. Problem-based Learning. Let's begin with the first type of research-based teaching methods. It is known as Constructivism. Constructivism is a learning theory that is established by reflecting on real-life experiences. It emphasizes the importance of prior knowledge, beliefs, and skills brought to the learning experience. The important aspect of constructivism is the learning constructed through interactions of prior knowledge, beliefs and skills, new information, and readiness to learn. Click on the buttons in order to view some features of constructivism. Here are some features of constructivism. Autonomy and initiative of students are accepted and encouraged. An open-ended question asked by the teacher who allows wait time for responses. Higher-level thinking is encouraged. Students are engaged in dialogue with the teacher and with each other. Engaged in experiences that challenge hypotheses and encourage discussion among students. The class used raw data, primary sources, manipulatives, physical and interactive materials. The second type of research-based teaching method is contextual learning. Contextual learning is a learning theory that occurs in close relationship with real-life experiences. It occurs in close relationship with actual experience, allowing students to test academic theories through real-world applications. Contextual learning is also referred in various terms such as experiential learning, real-world education, active learning, and learner-centered instruction. Click on the buttons in order to view some features of contextual learning. Here are some features of contextual learning. Connects a student's existing knowledge with new information and skills. Creates meaning by linking academic knowledge to the student's real-world experiences. Challenge students to think for themselves. Make students responsible for their learning. Give students freedom to explore and grow. Ask students to accept and respect each other. Ask students to evaluate and correct their own thinking. Allow students to work at their own pace. Accommodate differences in learning styles. Identify objectives and insist upon quality performance. The third type of research-based teaching method is cooperative learning. Cooperative learning is a learning theory that emphasizes maximum learning situation which occurs when students of all levels work together in structured groups towards a common goal. As indicated by Johnson and Holub, 1994, cooperative learning is the instructional use of small groups through which students work together to maximize their own and each other's learning. Cooperative learning classrooms are classrooms where students are likely to reach higher levels of achievement, to increase time on task, to develop cross-ethnic friendships, to experience better self-esteem, to build lifelong interaction and communication skills, and to function as productive members of society. Click on the buttons in order to view some features of cooperative learning. Here are some features of cooperative learning. Keeping the size of the group small for greater individual accountability. Giving an individual test to each student. Randomly examining students orally by calling on one student to present his or her group's work to the teacher or to the entire class. Observing each group and recording the frequency with which each member contributes to the group's work. Assigning one student in each group the role of checker to explain the reasoning and rationale underlying group answers. Having students teach what they have learned to someone else. Problem-based learning is a learning theory that emphasizes the use of pedagogical and curriculum development system involving problems of real-world situations. In a problem-based learning curriculum, students are presented with a problem and work in collaboration with each other to find solutions. During the process of solving the problems, students learn new knowledge, problem-solving skills, and associated skills of teamwork, leadership, and communication. The problem-based learning is highly context-specific. It serves to teach content by presenting the students with a real-world challenge. Problem-based learning is more inductive, where students learn the content as they try to address a problem. Click on the buttons in order to view some features of problem-based learning. Here are some features of problem-based learning. Select authentic assignments from the discipline, which are relevant and meaningful to student interests. Introduce content through the process of problem solving, rather than problem solving after introduction to content. If the case has some relevance to students, then they are required to call on what they already know or think they know. Choose real or contrived cases. The content is grounded in the kinds of challenges faced by practitioners in the field. Require students to analyze their own problem-solving strategies. Select cases with information that makes simple solutions difficult. While the solution may address one part of a problem, it may create another problem. Have students work in small groups in order to address the presented case. In this topic, we have looked at the 4 research-based methods in teaching mathematics, namely Constructivism, Contextual Learning, Cooperative Learning, and Problem-based Learning. These methods differ from each other based on their specific features and how they should be conducted in the classroom. We have completed the research-based teaching methods in the previous topic. In this last topic of the Methodology in Teaching Mathematics module, we are going to learn about the daily lesson plan. For your information, the daily lesson plan is crucial in teaching mathematics. All teachers at different levels need to prepare and deliver their daily lesson plans with the aim of helping students to move systematically towards learner goals. Daily lesson plans vary widely in the style and degree of specificity depending on the lessons to be taught. Therefore, the teachers need to make wise decisions about the methods and strategies they will employ regardless of the format. There are many formats in preparing a daily lesson plan, specifically in the lesson development section. Before we look at the formats, let's see the items included in the daily lesson plan. The items are instructional learning objectives, content, prior knowledge prerequisite, materials, resources, noble values, set induction, lesson development, conclusion, evaluation, assignment, and self-evaluation. In this section, write the learning objectives of the lesson you want to teach in behavioral terms. You should emphasize what you want and need your students to achieve at the completion of this lesson or class. There are 3 categories of understanding that you should consider in developing your lesson instructional objectives. What should students be familiar with, important to acquire, and achieve enduring understanding? We want the students to be familiar with concepts, ideas, and general knowledge. We want the students to acquire facts, concepts and principles, skills, processes, strategies, and methods. We want the students to get what are the big ideas and important points that we need them to retain and use. In this section, write the content of your lesson to meet the instructional objectives and strategies that you have developed in the earlier section. For simplicity and accuracy, the content should be listed using numbered bullets. The lesson content must be adequate and at the appropriate level of students' understanding. In this section, write the conceptual knowledge and technical skills that students already possess to begin the lesson. You should also be aware whether the required conceptual knowledge and technical skills are built on concepts or ideas that you have previously covered or that covered by another course. In this section, list down the materials or resources that you plan to use in your lesson. The materials or resources can be grouped into 4 different groups, namely 1. Printed materials, 2. Supplies, 3. Internet resources, and 4. Others. These related materials or resources should be useful and attractive to the students. Click on the buttons to view explanation for each group. Textbooks, lab manuals, reference materials, handouts, etc. any special items or equipment that you need to gather or request. Web addresses, URLs, of online resources that support what you are covering in this class. Guest speakers, mentors, etc. In this section, state the noble values that can be fostered during the lesson. Write cooperativeness if you plan to use group discussion. In this section, try to induce in the students an appropriate set of activities that is a predisposition or receptive mood that will generate interest and attention. Generally, there are three basic aspects that need to be accomplished at the beginning of any lesson in the set induction section. These basic aspects are to, number 1, use an interest approach, 2, put the lesson in context, and 3, provide advanced organizers. Click on the buttons to view an explanation for each basic thing. It is necessary to maintain students' interest in the lesson, even with those who are motivated to learn. Effective interest approaches should create a felt need on the part of the student to learn the materials in the lesson. Examples of effective interest approaches consist of raising perplexing questions, showing specimens or samples, presenting a case study, showing pictures of success and failure, and giving a skillful demonstration. An interest approach is anything that you can do to get the student's attention and interest in a lesson. It should be used at the beginning of every unit, every lesson, and every class. These are the types of questions that you should answer during the writing of the induction phase. Where does this lesson fit in the flow of the unit or the course? What have students learned in the past that applies to today's lesson? What leads to this topic? As you can see, a brief review of previous lessons as they apply to the current lesson is appropriate and helpful. It helps students to understand the links between past and present learning. An advanced organizer gives learners a conceptual preview of what is to come and helps them store, label, and package the content for retention and later use. Burridge, 1992, page 221. There are a number of reasonable ways to achieve this. The teacher is advised to write the performance objectives on the board before class and then announce them to the class in most discussions of competency-based education. Make sure that your students know early in the lesson what they are expected to learn. Provide additional advanced organizers as you change from one topic to another or from one activity to another. In this section, elaborate the content of the lesson. You have to explain how lesson builds on what has been studied and how it is connected to what students will be learning in the future based on knowledge, research, and theory. If possible, explain how lesson content is integrated across the curriculum. Basically, there are various formats that can be used for developing this section. Following is some of the examples that you can choose: Format A, Format B, Format C. Click on the buttons to view examples of the format. In this section, tie all the contents and conclude the lesson that you plan to teach. you should stress the important ideas, what they have to do with the student's world, and where he or she will see and use the information. Besides that, you also need to provide them with the most important points to remember. In this section, explain how you determine that the students have learned what you intended to teach them. Select a systematic means of assessment, which is paralleled with your objectives in order to analyze and document student progress. List follow-up activities according to your students' needs. There are 3 different levels of evaluating, namely 1. Reinforcement, practice; 2. Remediation, reteaching; 3. Enrichment, extension. In this section, summarize the results of your evaluation of student learning. You should also identify strengths and weaknesses in each domain of your lesson in order to improve, and also use this information in planning future lessons. In this section, choose suitable assignments that can enhance and develop students' skills and knowledge. Before you end your lesson, announce the assignments that students have to do or complete. In this topic, we have looked at the daily lesson plan, which consists of 11 items, namely instructional objectives, content, students' prior knowledge, students' prerequisite, materials, resources, noble values, set induction, lesson development, conclusion, evaluation, assignments, and self-evaluation. The daily lesson plan is very important as a guideline for teachers. Thus, teachers at different levels need to prepare and deliver their daily lesson plans with the aim of helping students to move systematically towards learner goals, besides helping them to understand